Welcome. Today, we are exploring the Flutter App Template, a strategic blueprint designed specifically for data-centric applications. As mobile applications grow in complexity, the need for a scalable and maintainable architecture becomes paramount. This template provides a solid foundation for apps that must integrate seamlessly with intricate backend services. Looking at the architectural map surrounding the device, you will notice a highly modular approach. We utilize the repository pattern to abstract our data sources, allowing for flexible integration with REST and GraphQL APIs. Business logic is strictly contained within the domain layer, while feature modules ensure that the codebase remains organized and easy to navigate as the project expands. Key infrastructure elements such as centralized state management, dedicated data and event buses, and robust authentication protocols work in harmony to ensure data integrity and a smooth user experience. This blueprint is more than just a starting point. It is a proven roadmap for building high-performance, enterprise-grade applications in Flutter.
This architecture is engineered for scalability. Far beyond a mere starter kit, it represents a rigorous framework designed to separate concerns effectively, specifically optimized for data-centric applications that rely heavily on backend services. The first pillar is our layered architecture. By implementing a logical separation between the presentation, domain, and data layers, we ensure that each component of the codebase has a distinct responsibility, which simplifies both maintenance and testing. Secondly, we utilize a multi-package structure. This modular approach, managed via Melos, allows for a highly organized workspace where core utilities and specific packages can be developed and versioned independently, facilitating better team collaboration and code reuse. Finally, our focus on data-centric design provides robust handling of backend responses. By integrating API response validation, comprehensive error handling, and a data integrity shield, we guarantee that the application remains stable and reliable when processing complex data from the database backend.
The foundation of any scalable application is disciplined package management. To achieve this, we utilize Melos to orchestrate a multi-package environment, which ensures isolation and dependency control from the start of the project. Looking at our component setup, the Melos root acts as the central orchestrator for the entire monorepo. We categorize our packages into three distinct pillars: App Core, Feature Modules, and Shared Libraries. The App Core handles foundational logic, such as our core UI and networking layers. Feature modules are separated by business domain, specifically authentication, dashboard, and settings, to allow for modular growth and independent testing. Meanwhile, shared libraries provide common resources like data models and utility helpers that are used across the entire codebase. This structured approach establishes a clear dependency graph, allowing us to effectively manage complexity as the application scales. Our package architecture is designed to optimize maintainability and testability by dividing the codebase into clearly defined logical layers. This structure follows a strict dependency flow, where each layer primarily interacts with the components situated below it. Starting from the top of the stack, we utilize Go Router to manage navigation and routing. This sits above our state management layer, which leverages hooks and RiverPod to handle application logic and data binding. The presentation tier is split between UI components and a centralized theme package to ensure visual consistency across the application. Beneath these, the adapter layer functions as an intermediary, facilitating communication between the interface and our underlying data structures. At the foundation, we define our core domain entities using model and freezed to ensure data immutability and integrity. By adhering to this layered architecture, we isolate concerns and maintain a scalable, easily testable codebase. Data modeling and immutability are foundational to achieving robust data handling. By utilizing immutable objects, we ensure that data remains consistent and predictable throughout the application lifecycle. Our architecture specifically leverages freezed classes to safely hold and manage responses returned from backend services, which minimizes the risk of unintended side effects. For further technical details on this implementation, you may refer to the source files for the package model and freezed classes. Connectivity and adapters are managed through the O3_package adapter layer, which is specifically dedicated to interfacing with external systems. By utilizing the DIO package to communicate with RESTful services, we maintain a strict separation between API integration logic and the user interface.
This architectural boundary, supported by the DIO client implementation, ensures that external communication remains decoupled from the presentation layer, enhancing the overall maintainability and testability of the application. Hybrid state management provides a dual strategy approach to control the flow of information with maximum efficiency. We utilize RiverPod to handle cross-app data access, ensuring that global state remains consistent and accessible throughout the entire application. Complementing this, we leverage Flutter hooks to manage the internal widget lifecycle. By combining these two powerful tools, we effectively decouple global business logic from localized UI behavior, resulting in a more maintainable and scalable architecture. Our navigation logic utilizes the 07 Go router template to implement simplified, declarative routing across the application. This architectural choice is specifically designed to support complex page transitions and provides deep linking capabilities right out of the box. Looking at the structural diagram, the home page acts as the primary hub, directing traffic to the profile, settings, list, and search modules. Within the list module, the routing logic further extends to individual details pages. By using Go Router as our foundation, we ensure a robust and easily manageable navigation flow throughout the user journey. Our UI and theming strategy focuses on maintaining design consistency by isolating visual definitions within 04_package_theme and UI components within 05 package UI. This modular approach ensures that style updates can be managed centrally without disrupting individual component logic. Furthermore, we have integrated 08 Google Fonts to facilitate robust and uniform typography management throughout the platform. Our technical ecosystem is driven by a robust mix of languages that form the foundation of our project structure and build systems. Dart serves as the primary language, accounting for 67.1% of the codebase. This core is complemented by C++ at 15% and CMake at 8.2%, which are instrumental in managing our build processes. Smaller but essential portions of the project utilize HTML, Ruby, and Swift to address specific cross-platform requirements and automation tasks, resulting in a diverse and highly functional development environment. Focusing on software engineering, our commitment to developer experience and tooling is built around two main goals: productivity and code quality. To maintain high standards, we implement comprehensive linting rules with minimal exceptions, ensuring that our codebase remains consistent and readable. We also prioritize automation to streamline our workflows. A practical example of this is our custom Melos task, designed to automatically generate launcher icons. As demonstrated in the terminal snippet, this automation handles the asset generation and placement directly into the UI directory, significantly reducing manual overhead and minimizing the risk of errors during the development process. This architecture summary outlines the four key pillars of our technical foundation. First, we maintain a modular structure using a multi-package approach managed by Melos, which ensures clear boundaries and enhances code reusability. Second, we prioritize a type-safe environment by enforcing immutability through the freezed package, significantly reducing the risk of runtime errors. Third, the system is designed to be scalable by strictly separating API logic from the presentation layer, allowing the codebase to grow without increasing complexity. Finally, we adopt a modern development workflow by leveraging RiverPod and hooks for efficient reactive state management. This template is currently in its alpha version. To refine this data-centric blueprint effectively, we highly encourage active review, collaboration, and feedback through the discussion section. Your participation is essential to the development and improvement of this project.